Okay, so this is the whiteboard diagram copy of the diagram that's in the book on page 358, dealing with 8K, number 4. Okay. The first question they ask is, what's the probability of picking a person who's in set A but not in both A and B? So if you look at the Venn diagram, it's actually pretty easy to figure out. If you're looking for a person who's in A but not in both A and B. Okay. So you're picking a person that's in this side of A person in A, but in the complement of B. So that's A intersect B complement. That's this set right here. They're in A, but not in both A and B. By saying they're not in B, that's the same as saying they're not in A and B, because we start with something that's in A. Okay, so we want these 12. So this probability will be 12 on the top, and then the total number on the bottom. And you notice in this one, there's actually 10 more individuals outside over here. So we have to add all these numbers for the denominator. So that's 12, 18, 24, 34 individuals total, 12 of them fitting this requirement. Now that number can be reduced because its top and bottom are both even, and actually they're both divisible by 4. So this is 3. Well, let's see, let's start it with 2. We go 6 and 17. There we go. That's lowest terms. You should always reduce your fractions to lowest terms. Don't put them in as a decimal, especially a fraction like this, because the decimal will be very messy looking. Okay, let's look at the next one. What's B say? B says what's not in A and not in both. All right, so it's not in A and it's not in both. So if it's outside of A, that includes these two. And it's not in both, well, it won't be in both either if it's outside of A. So that'll be these two put together. That'll be the 10 and the 6. So this will be not in A and not in A and B. So that's the way you'd write it out, but it actually turns out to be not in A is exactly what it is, A prime. That's these 16, and there's 34 total. Okay, so once again, that reduces to 8 over 17. Okay, and this would be your answer. Well, let's circle this one. Okay, we could reduce it to that one. Okay, what's in C? All right, in C they ask what's not in both A and B. So if it's not in both A and B, that's A intersect B complement. Well, there's 6 in the intersection. That means everything that's not in it is everything outside. So that's a total of 10, 16, 28 out of the total, which is 34. And once again, we can divide that by 2. We get 14 17ths. Okay. Now, what's we? We're getting it. We haven't done anything in doing conditional probability yet. Now, what's not in A given they're not in B? Now, this is the probability of, well, let's just use it as a set right now. The probability that they're in, well, let's write it. The probability of A given they're in B. That's what it says. The probability that it's in A given that they are not in B. Okay, not in B means B complement. All right, so it's in A given that it's not in B. So we know it's not in B. We want to figure out the probability that it's in A. Okay, we can look at the formula, and you can see how to work it here. Remember that the thing that comes second is the condition. That goes on the denominator. Okay? The thing that comes first is intersected with that for the numerator. But the fact is, the easy way to conceive of a conditional probability is that whatever the condition is, just look at that set and forget everything else. So when I'm looking at B prime, I'm looking at everything outside of B. I'm looking at this 12 and 10. That's my new universal set. That's my new denominator. That's the part I'm going for. That is B prime. So I'm looking at 22 on the bottom here. That's the B prime population. Now what goes on the top is what's in, I only have to look at that, what's inside of A. See? I'm looking for what's in A given that I'm outside of B. Well, there's these 12. See? Those 12 are in A and at the same time outside of B. So this fraction right here is the conditional probability. Once again, you can reduce it, 6 over 11. Let's just circle it like so. All right, so when you're figuring conditional probability, looking at a Venn diagram, it's really easy. I don't have to use the probability formula. just use the numbers that are in here. The denominator number is the condition, and the numerator number is the part of the condition that fits your first part. We'll do another one. What's E say? E says, what's the probability it's in B given they are in A? So this is even more direct. What's the probability it's in B given that it's in A? Okay, so once again, I think it's always easiest to start with the denominator. So the denominator is A. That's the set we're looking at. That's our new universal set, these 18 individuals. How many of them are in B? Well, these 6 individuals. So that's 1 over 3. All right, 6 over 18 is the unreduced part of it. All right. And now let's move on to the last one. What's the probability it's not in A given they're not in B? All right, so what's the probability they're not in A given they're not in B? Okay, so once again, I think the easiest way to start with, let's make sure we're in the screen here. A little bit low. Let's move that over here so it's easier to see. Let's say F, we'll put right here. What's the probability they're not in A given they're not in B? Okay. Well, the denominator is easier to first. Let's just look at B prime. B complement is 10 and 12. That's 22. Then I look for the part. I'm only looking at outside B complement now. I forget about these other ones. This is my universal set, these 22. Now, the probability of A prime, that means not in A, at the same time being not in B, that's the 10. Okay, so that reduces to 5 over 11. Okay. Now, all those put together form the answers to 8K number 4. Okay? Now, all I want to do here is say that everything I've circled, you'll see, if you look up the answer in the back, is what the circled values are. The circled values are what you find in the back, but I would think in every case, they should be simplified to lowest terms. All right? They're not requiring you to do that in the book, but I think it's a good habit to get into so you can compare them head to head. All right? So always reduce your fractions to lowest terms, even though the book doesn't reinforce this. I think that's a good practice to get in so if you're comparing probabilities. Okay, that concludes the solution to 8K number 4.